Event is a nonprofit organization, and the work that we do year-round to help these students ideate and incubate inventions for social good, and events like Demo Day, connecting those students to industry professionals, are all made possible by donors like yourself. Project Event is able to train teachers, run today's event, and support teams because of the generosity of our community. So please consider donating.
Hi, I'm Samhita.
My name is Maximilian Chavez.
My name is Carmelita Lee.
Our product for today is for children with autism because they find it extremely hard to identify their emotions and cope with stress.
We created the Beta Band, which is essentially a headband. It reads your beta waves, which fall in between a certain low and high beta wave, and if you're outside that range, then your brain is not acting as a normal brain.
Project Event has definitely impacted my sense of teamwork. I can collaborate a lot more with my peers, have that design thinking into mind. How can we target our users and have the best influence and the greatest impact on their lives?
Working and coding and doing all that stuff, it gave me a chance to be familiar so that I'm not as intimidated going into college. And it's actually made me a lot more excited for freshman year of college.
We've definitely opened our minds up a lot more, and we've learned how to cope with maybe our product not working and still learning from our mistakes.
Having interacted with people who are on the spectrum, young adults and little children, and seeing what they go through and understanding their experiences, and then being able to put that into a product, engineer something, and then see that truly affect them and help them.
A lot of people try and create products for people that they don't even they've never even talked to before. So we had a lot of things that we thought would be good, but after talking to people who actually use wheelchairs, they were we don't have problems with that. So it just you really should talk to people and get to know them before you make assumptions about things that they struggle with.
I think the impact has been huge, and it's changed my outlook towards for project-based learning and education a lot, actually. The reason is because prior to Project Event, I focused a lot on just developing technical skills and having the students learn laser cutting, 3D printing, soldering, sort of for the sake of learning 3D printing, laser cutting, and soldering. But working with Project Event and anchoring these technical skills to a real-world problem has really, I think, made the learning experiences more meaningful for the students so that they understand what the application is, and has helped with retention and student involvement. It's been really great.
None of these girls came into this project thinking that they were inventors or makers, or that this kind of thing was something they even wanted to do. All of them, I believe, have been radically transformed just by this idea that the world is invented, right, and designed, and that they can participate in designing that world, right? I watched them gain confidence interviewing people, really understanding and delving into design thinking and human-centered design. I watched them struggle through prototyping and then succeed and feel really empowered by that. We have 4 women here who are ready to take on the world and change the world with the invention that they're making, and this is not something that they would have even considered doing in September of this year.
It's been really amazing being able to turn a problem into a solution just through engineering. And so I think Project Event has taught me that anything that you see out in the world, if you think there's a way that you can fix it, it's totally doable, and that there are resources out there and people out there willing to support you throughout the journey.
This is bigger than just us.
All right, now without further ado, let's meet our panelists. Our first panelist is Dave Beardsley, head of Model Shop Google. Welcome. Dave, in a quick sentence, what are you most excited about seeing from our students today?
Oh boy. I did this last year and was just absolute they have to share. So yeah, that's it from my side.
Thanks, Dave. Our second panelist is Vinny Chakrata, MBA student at Stanford University. Welcome. So Vinny, what are you most excited about seeing from our students today?
I'm just excited to see all the interesting and creative solutions that you guys have come up with to solve really meaningful problems. It's just incredible what you guys are doing.
Thanks, Benny. Our third panelist is Max Yoshimoto, professor at San Jose State University. Welcome, Max. What are you most excited about seeing from our students today?
Yeah, thank you. Yeah, I'm very excited to just see the energy that's brought to all these projects. So really looking forward to it.
Thanks, Max. And our fourth panelist is Killian Evers, Senior UX Director at Google. Welcome. Killian, what are you most excited about seeing from our students today?
I am so excited to see all of the great design thinking and the great experiences that you are bringing to all of the community partners that you have been working with.
Absolutely. This event is sponsored by ThoughtSpot, and we're so thankful to them for helping make our demo day possible and for providing the $2,000 of funding for the prizes awarded today. 2 teams will be awarded. Now that you've met our panelists, it's time for the main event. Each team will have 5 minutes to pitch and 4 minutes for questions from our panelists. A quick reminder to our amazing student teams before we begin: you've done the hard work, you've identified your problem to solve, you've designed and you've redesigned and you've redesigned again. You've interviewed users, you've spent your dozens of hours coding and building circuit boards, and so much more. Now is your time to celebrate that hard work, to show off what you've done, to advocate for your invention, to learn and grow with some of the best professionals in the industry. So take a deep breath, shake off the nerves, and have fun with it. So let's do this. Our first pitch is Community from the AMP Lab at Electric Works, Fort Wayne, Indiana. Community offers a hands-on way for students to communicate with others that is effective, direct, life-changing, and affordable.
We are Community, a business venture that started as a passion project. We are focused on those that are nonverbal. Hi, I'm Seth.
I'm Emily. And I'm Adrian. We all love our families. All 3 of us have a friend or family member who is nonverbal. For example, my little sister is nonverbal and has troubles communicating, especially in the classroom. And it's really hard for me to watch her go through this. As we know, communication is an essential part of learning. But for many nonverbal students, communication is a challenge they face daily. Current solutions for this fall between 2 extremes, either excessive high-tech or inefficient low-tech.
That's why we created Community. We wanted to give students in a classroom an easy way to communicate with their teachers, as well as not drawing attention to themselves in a classroom. We achieved that by using customizability in our tablet as well as Bluetooth.
Our main demographic is teachers who deal with nonverbal students in a classroom setting. With over 2.9 million students in the U.S. not being able to communicate verbally, another market is families with nonverbal children in their homes.
Our current target price for customers is $150 per tablet, with production costs being $55.75 per tablet. We'll have a profit margin of 66.63%. The graph shows a complete breakdown of all our products used, from filament all the way to electronics. Our product is a fraction of the cost while still maintaining a high profit margin.
Our community partners that we partner with over the past couple months are Adams Elementary and Memorial Park mainly. We've met with a couple students there who have really gave us a lot of knowledge and insight on how it works in the classroom for nonverbal students and what they need and what they're going to do. And we've really gotten a lot of good feedback from them and used it to further our device.
Now let's talk about our competitors. On the screen we have 2 categories our competitors fall into: high-tech options and our low-tech options. Example of high-tech options is a computer program called LAMP, Dynavox, and AAC Institute. A lot of their prices range upwards of $400, even closer to more in the thousands, as well as they're very overstimulating for kids, giving them too many options or too little options to use, as well as the students don't really love using them. When we went and tested, we found that a lot of them would rather struggle with the device in their hands than use it to communicate. And then the other option is low-tech options, which fall under things like sign language, pointing, and flashcards. We found that a lot of these are really hard to communicate with the teacher in a classroom of upwards of 30 plus students, as well as it draws a lot of attention to the student, causing them to be embarrassed or scared that they could be made fun of for being nonverbal.
The solution to this problem lies in developing a mid-tech solution that balances high-tech and low-tech approaches. With affordability is and will always be our main focus. With a mid-tech solution, there isn't any hard training or complicated menu that would get a child overstimulated. With interchangeable pieces, it can be fully personalized for each student, making it more versatile.
Our first prototype was a rough draft of what we wanted our product to be. Throughout our prototyping, we visited Adams Elementary and Memorial Park, as we talked about, and we used the feedback from those students to further improve our device. We simplified it with just the simple of the pressing of the button and it lights up, and we moved on to having a Bluetooth feature where when the button is pressed, it will light up on the device, as well as send a Bluetooth signal to signify a badge holder on the teacher to light up and buzz.
Now, where are we going from there? Right now we are working to get the Bluetooth in the classroom so we are able to test that, as well as continuing to test our device through beta testing. We are also talking to lots of consumers, customers, like the teachers, administrators, students, families of those nonverbal kids, and we've gotten a lot of feedback from them. A lot of them have even offered to be our first customer when we put it up for sale, as well as continuing testing with them.
The affordability and adaptability of our product allows it to be accessible to a wide range of markets. This ranges from things like nursing homes, hospitals, and even moving further into these child's lives as they reach high school and college. This helps our product change as many lives as possible. Thank you.
Community sounds like a great product for improving communication in the classroom. Team Community will respond to questions from judges for 4 minutes now.
Hey folks, I was wondering if you could talk a little bit about the particular challenges and changes that you had to make in your prototype that you alluded to in your presentation.
I think one of the big things that we really struggled on was we originally wanted the tiles themselves to be buttons, and we were super ambitious about it. Like we fought really hard to try to get these tiles to be buttons that lit up underneath, and it just did not work out in any way. Like we tried like any kind of glue and sticks you can think of, just trying to get it to stay up. And then we eventually also moved on with we changed the sizing of our device to better fit the portability and like being able to move it around, especially these kids go to gym class and things like that. So we listened to what I think one of the children said they did want to be able to carry it places. So yeah.
Yeah, hi. I was wondering, was there a particular moment in time that you guys discovered like a big part of the puzzle that allowed you to get to where your current solution is?
Can you repeat the question, please?
Yeah, sure. I just was, through the process, you guys are like kind of experimenting and prototyping. I'm just curious if you could just let us know when in that process was like an aha moment of like, oh, wow, we should really do this or take on this kind of solution for the product.
I think in the very beginning of our product, like when we first came up with the first concepts of it, there was no Bluetooth aspect that we really thought of. It was just the simple, oh, we're just going to make a tablet that like you press a button, it lights up. And then we really thought about it because we were like, how is this really different than other things on the market? So then we kind of like thought, what would you need in a classroom? And one of those things was
attention from a teacher. So we kind of thought like, how are we supposed to get this attention? And that's where like the Bluetooth kind of came in. We were kind of like, with Bluetooth, you can have something separate on the teacher and it gets their attention without disrupting the class. So that was like a really like aha moment, I guess.
How did you guys actually do I'm curious, the communication between the tablet and whatever the teacher is holding on to? So you said Bluetooth, but I would love if you could describe it a little more.
My other teammate, Seth, who is currently not here, as well as Emily, apologized for their absence. Emily had a tennis thing she couldn't reschedule, and then Seth is sick. But from what I know from the Bluetooth standpoint is I believe they're all the wires are together in a circuit inside the device itself. And when one button is pressed, it sends a single like signal through an Arduino to another Arduino inside the badge holder that like basically signals it to like buzz and light up as long as that button is being pressed. So you can press any single button on there and it will like make it Bluetooth. And then once you like, I think push up the button again, because they like the latch ones, once the button releases, then the signal stops and then the badge holder stops buzzing.
Got it. Thanks.
Thank you.
So I really liked how you guys were, working with the students and, reacting to their feedback. Was there any feedback that kind of came out of left field that you weren't expecting and you're like, oh, I didn't think of that, and or was most of it kind of what you expected to see?
We actually spoke to this one nonverbal student at I believe Adams Elementary School. She's a third grader named Angel. We gave her one of our feedback sheets that we created, which is we picked like 30 tiles, possible tiles, and we put them all on a piece of paper with the icon and the word. And we gave this sheet to her and told her to like circle her favorites and like X out the ones she would never need. And we found that she personally really wanted one that was more emotional based. Things like overwhelmed, sad, confused, help, as opposed to things like pencil, pen, and stapler like we originally put it into our device. So it was kind of like, it really opened our eyes to like what a nonverbal student could possibly want in the classroom.
Doja, the team community, thanks so much.
Thank you.
Yeah. All right, we're moving on to our second pitch, which is Pearl from the School of Science and Math in Durham, North Carolina. Pearl is a jack-of-all-trades aquatic sensor rod that can adapt to local environments and utilizes multiple aquatic sensors.
I'm Jess.
Hi, I'm Kelvin.
Hi, I'm Nikki.
And I'm Eric, and we are Team Pearl. How many of you like driving? It might be enjoyable for half an hour, or maybe a whole hour. Now imagine having to drive 3 hours to your job, only to realize that there's no work left for you to do. Or that after spending 5 hours driving and getting ready to work, realizing that the weather is too bad for you to do anything, which is primarily outdoors and in the water. This is Benji, our community partner. He's an oyster farmer, and he drives 3 hours from his home in Durham to his farm in Swansboro, North Carolina. Every weekend, Benji commutes 3 hours to his farm, but when he gets there, he can't immediately get to work. He has to put on his pants, boots, waders, which is basically like a dry suit, prepare his boat, wash his buckets and equipment, and he has to take readings on his site, which include metrics like humidity, temperature, salinity, and mineral levels. In doing that, he will have spent another 2 hours.
Here's the problem. It takes him 3 hours to drive from Durham to Swansboro, and 2 hours to prepare for work. But if those ratings weren't stable enough at the end of the preparations, Benji can't do any work. So he has to take another hour to undress, pack his equipment, secure his boat, and clean off everything that he used, and then drive another 3 hours home to Durham. Every trip from home to farm and back costs $80 in gas and consumes 8 hours of Benji's time. simply because he has to take these readings manually and on-site.
8 hours and $80 might not sound bad for a weekend, right? But it adds up. Benji has been leading in this routine ever since he started his farm over 3 years ago. It rains almost a third of the time in Swansboro, meaning that on average, he wastes a total of 2 weeks in the car and over $4,000 in gas and materials each year. So what if he didn't have to lose that much time and money? Pearl is a unique sensor system that intakes ocean water, instantly providing Benji with readings from his farm at home to remove unnecessary travel time.
We started out with a lot of really weird ideas. When I say weird, I mean like weird. It all started with just a sticky note back in March. Before, Benji took precious time to collect data manually. Pro can now automatically do that. Additionally, there is an antenna that can send readings to Benji's email. We also programmed a dashboard which can give Benji a view of environmental trends, which is invaluable to helping him make decisions.
This is a reconstruction of Benji's farm. Pearl has multiple sensors which stick into the ocean, and we've set our computer up to make a noise when the salinity or the turbidity change dramatically in the water. But wait, there's more. Pearl can take multiple types of readings, cater to the user's preferences, and these are sent directly to the company or the user.
In one of our interviews with Benji, we learned about something called TIM. TIM is not a person, standing for Tide Information Monitor. It initially seemed like Tim could do everything Pearl could. This was a huge setback. We were stuck for weeks before we realized that we could generalize our product. We spoke to Benji's friend, an oyster farmer in Cape Fear, and we realized how much utility a general purpose product could have for many other farmers.
So, there's other solutions to environmental monitoring besides TIM and Pearl. This is a public weather station, and these are Benji's current sensors. Now, what do these all have in common? Well, they take environmental readings. With the weather station, there's several hours of delay before conditions are reported, which is just not enough for farmers. Single sensors are great at doing their job individually, but take much time and are often extremely expensive. Pearl is generalized to be used anywhere and everywhere.
Fancy tech, right? For its feature set, Pearl is highly affordable. Benji's family spent $300 and 2 years to make TIM. Imagine how much time that could save, not just for Benji, but for other oyster farmers, and for anyone with a use for aquatic sensor technology. In the future, we hope to distribute it to consumers such as environmental researchers and other aquatic farmers as well. We foresee that Pearl will have a positive impact not only on the lives of individuals as farmers, but as a whole will reduce hundreds of hours of driving time per year for so many people who work near the coast. We also recognize that Pearl can get a lot better. We're attempting to implement additional sensors and modularity, which would enable consumers to pick and choose which data they collect from the water, scaling and customizing cost and precision. We hope to publish our dashboard and all the other software that we've written as a library on the Python package index, significantly increasing Pearl's ease of installation. Thank you so much for listening. We're Team Pearl, and our oyster is your world.
Such an interesting community partner. Great job, Pearl. Team Pearl will now have 4 minutes to respond to questions from our judges. Go ahead.
Yeah, I have a question. So great amount of context that you guys provided about the product. Can you just, in the most simple terms, explain like what the core problem was? Because I think you talked a lot about driving time and losing time and spending time not doing work. But what was the core problem that you guys were solving for? If you can just really explain it simply.
Yeah, absolutely. Ultimately, it was sort of a logistical problem, and this is something that it took us a lot of time meeting with Benji, our community partner, to realize. Both Benji and a lot of his friends that work in similar fields have farms that are obviously near the coast because of the nature of their work, but due to family situations and economic situations, they don't have the ability to live close by. As a result, a lot of their work results in a very long commute. And because of that,
and a lot of the environmental conditions that exist out there, such as bad weather, maybe just bad conditions, especially in the water and in the atmosphere, which sort of poses a double problem, means that they have to go there right now. They have to go there not only to do their work, but also to figure out whether they can do the work in the first place. So what we're seeking to do with Pearl is to sort of accomplish that task remotely and autonomously, removing that commute for any waste trips that they may have.
I have a question. I thought you guys did a great job with setting up an example environment, just to mirror what it would look like in actual ocean conditions. I would love if you could talk a little bit more about how you thought about building that example environment to test your sensors.
Yeah, and a part of our example environment was sort of a part of our product development cycle. As similar to Benji, we do not live near the coast. It was really important to bring a simulation, even if it was imperfect, to sort of model the behavior more economically, more efficiently. We got a fish tank from our biology department, and sort of recognizing that, hey, this is going to go in water. We have most of the minerals are actually in seawater. We can test our product and we can make sure that at least it has a general performance before we move on to further phases. So this was sort of like our logical design process, which again, we learned a lot from our community partner who told us about his journey through making that tide information model, that Tim, a lot of that iterative engineering processes, we had to adapt to that given our resources.
I have a question about the generalized use that you talked about. You alluded to other farmers or other opportunities. Can you elaborate a little bit on how you see this product extending into the broader market?
Absolutely. A big portion of our later talks with Benji, and Jess was a part of this as well. We talked to one of Benji's friends who does not actually farm oysters, but does have a lot of work regarding environmental situations in the water. They're developing a sort of new technology in another part of North Carolina, and they said that they would really love to see sort of that remote real-time sensor technology as well. And so this gave us the idea of perhaps mentioning the efficacy of this product towards other fields like other types of farming and environmental research, both of which would greatly benefit from having your own weather station that's like more on time and cost effective as well.
Can you guys talk a little bit about how the actual device, all that stuff?
Sorry, you cut out for the last 5 seconds. Could you please repeat the question?
Sorry. I was just curious about the device itself. Was that like 3D printed, or how did you make that?
Yes, the construction of our device is, as you saw in the video, it was sort of not in a fully assembled state. We are working on a model that will be 3D printed. That was the most logical solution that we could come up with given our sort of engineering constraints and Jess was responsible for talking with one of the community partners about like the environmental conditions that are harsh. Saltwater and electronics are not good. We have learned 3D printing, sort of sealing everything up as best as we can. We will have to test this rigorously environmentally, but at least in our current setup, that level of construction is sort of what we're going at. So 3D printing, bolting everything together, making sure there's a good seal, and just packaging all of our electronics in there. And it's something that's nice with plastic is that signals can go through it. It's not, we're not building ourselves into a Faraday cage, so we can still enable our communications aspect to work.
All right, thanks Pearl, thanks judges. Let's go to our third pitch, which is Tilty Pot from Leaf Charter School in Alstead, New Hampshire. Tilty Pot is a countertop kitchen tool that holds and pours pots and bowls, transforming challenging kitchen tasks with automated assistance.
Hello, and you are here with Leaf's Chartered School in Alstead, New Hampshire. We are Team Tilty Pot. I'm the head of the team, Camille Branch, and the inventor of the idea. Off to you.
I'm Leo. I do coding.
I'm August. I did prototyping.
This is our community partner, Claire. She is a college student who attends WPI. She enjoys knitting, puzzles, theater, and cooking. Claire's EDS in POTS. People with POTS and EDS are not rare. There are around 500,000 to 1 million people diagnosed with POTS in the United States, and EDS is diagnosed to 1 in 20,000. There are also a large number of people who don't get diagnosed with either due to less severe symptoms.
Claire has EDS, which causes joint hyperflexibility, skin hyperflexibility, tissue fragility. Although being flexible is a good thing, when it comes to EDS, it means your limbs are easier to strain and dislocate. This difficulty has made simple things such as turning a key or holding a gallon of milk tiresome things to do. Which brings us to Claire's request, for us to create something to assist her with straining pasta. With this idea in our head, we started brainstorming on how to assist Claire. We studied POTS and EDS to find where our main focus should be, along with talking to Claire, making sure to get constant feedback. Team Tilty Pot has also got to know Claire on a personal level, learning about her schedule and things she misses being able to do, such as dancing and sports. Seeing how it affects people and leaves them unable to do things they love to do helps fuel our determination to create something to make it a little easier for Claire, our original community partner we had to pivot from since we couldn't figure out how to help.
This is Claire's kitchen. We ended up leaving the pasta tube and divided into two groups, the strainer pot and the tilty pot. Each group made sure to stay positive, but to ask questions and make suggestions to each other. We also went around and showed our idea to our teachers in our school, some of which gave us ideas on other uses for the tilty pot, such as pouring things with more precise measurements. The tilty pot has an ability to change how much or how fast the tilty pot will turn. During our time working with Claire, we learned that the path forward also has a few steps back. When we first made the tilty pot, we were working hard to make it the best it could be right off the bat. So when we met with Claire and got feedback, her questions and concerns let us discover things we didn't put much thought into or didn't think about at all. Things such as, I have limited storage in my apartment. I'm concerned I won't be able to store it in my kitchen easily, and I'm concerned about letting water fall from that height, causing boiling water to splash back at me. It might be safer to release the water at a lower level in the sink. These are some of the concerns our community partner talked to us about. Along with, I'm concerned about touching hot surfaces. To release this mechanism, it sounds like I would have to put my hand really close to the hot water. So is there a way that we could change the geometry of the handle to make it safer for me? Which sent us back to the drawing board, where we added on and built with Claire's concerns in mind. We made the tilty pot automatic and tilt slower, our feedback being, I think this will be able to fit into my kitchen. The feature of being able to lift any pot for me is really useful. This could be used for more than just pasta water, which is super great. I will be able to give this design many purposes in the kitchen. But by making sure to get enough feedback, we were able to make the tilty pot even better and accessible for Claire. This helped us learn that it doesn't have to be perfect the first time, and that one faulty part of an invention can lead you to an even greater improvement, along with being flexible and being able to pivot from one idea to another instead of being fixated on one idea, but also not giving up on one idea completely and staying in contact with your community partner and crew is the best way to overcome challenges. Claire's final thoughts being able to cook without wrist pain is going to be awesome. This is our competitor matrix. Sadly, we couldn't find anything similar to the tilty pot. Happily, that means we're original.
Our next step would be getting better, proper materials for our invention. We would get important things for a device to get it running for Claire.
Appreciate how much you listen to your community partner, Tilty Pot. So Team Tilty Pot will now respond to questions from our judges for 4 minutes. Go ahead.
Yeah. So it sounds like you guys were, and correct me if this is wrong, it sounds like you guys had a bigger team and then you split into two teams. What was that like in terms of how you decided which thing to focus on in terms of like how the team split and just like, what that meant for the product journey?
So we just started out as one big group and we brainstormed ideas, and then we voted on like 3 ideas on which we could like go into more depth with, and then we used the feud matrix to like limit it down to only 2 teams.
Right.
Yeah, hi, I was wondering is there a way, I love watching the presentation in the video and I saw it in your prototypes. Is there a way that you can explain to us how the Tilty Pot actually works? I saw the cardboard thing with the ramp and some gears, but I may have missed the actual like how that prototype actually works with the real pot.
So there's this box, and inside of it would be gears that would rotate a track. And there's this plate connected to this track where you put on your pot, and that would help rotate the pot. And then we made an adjustable height and kind of clamp to go around the top that would be with the pot. But it's mostly just the base with the motor.
What was the biggest skill that you think you learned as part of this investigation, as part of this whole experience?
Ambitious. Having to change community partners so quickly kind of really knocked us off our A train. But I feel like we were able to move on from our past partner and really settle on helping Claire.
Thanks so much, Tilty Pot and judges. All right, our 4th pitch is Silly Ducks from Burlington High School, Burlington, Vermont. It's a hands-free navigation solution for those with visual impairments.
The device that we built is an ultrasonic distance sensor. That's one of the components. And the problem this device is supposed to solve is navigating specifically around the school without hitting walls. Many people take this for granted, but not everyone is lucky enough to see everything or be able to see everything as clearly as some of us. Our community partner, Owen, is visually impaired. Going to school in a maze like this is difficult for everybody, and it's even harder if you can't see everything going on around you. So here, there's just a little mini demo of how our device is supposed to work. It's supposed to vibrate progressively quicker at 100 centimeter intervals. So the closer you get to a wall, the faster it vibrates. So how did we solve this problem? We decided to make a device that would help Owen with this by vibrating at faster intervals. We offered to Owen to make it beep, but he said he would prefer vibrations because he can feel the vibrations, and they would also be better in a louder situation. So the features of this device are targeted specifically towards Owen. We asked him about his likes and dislikes, and he told us how he really likes the color blue and likes stars. Taking into consideration that he likes things that he can touch and feel, we made a blue with raised stars design, so you can feel the texture of the stars, and both the front and the back are made of felt. So we know that not everybody likes these, but this is something that we could change depending on which audience we're targeting. So for Owen, this was what he liked best. And ideally, we would have a battery pack on the side with an on-off switch. But we still need strong enough batteries to support this device. So for testing purposes, we've been using a Chromebook as the battery. So how it works. We used a breadboard and an Arduino to program the ultrasonic distance sensor to, at the different intervals, let the vibration motor know how quickly and how strongly to vibrate. And as I said before, ideally, this be controlled by a battery pack. All of this rests in a felt-covered box that hangs around your neck with a felt strap. So here we have Duncan.
Hello.
I'm going to test this for us.
Okay, so right now, it's vibrating slowly. Here's the Chromebook. Can you hear? Okay. So I walk closer, so it's going faster. And if I get really close, it goes faster. Isn't that crazy? Look at that.
So the estimated price for our product is in the $40 range. Over here you can see the different prices that we factored in, and we bought everything. We looked at everything in bulk, because if we're going to be producing a lot of these items, we'd be buying a lot more, so the individual price would be a lot cheaper. One of our items is cardboard boxes. So ideally, this product in the future would be made with a more durable, harder shell than the cardboard box. So that is something that would probably raise our price. Here you can see the markup, overhead, material, and labor costs. Our competitor matrix. It is a pretty small matrix considering there are no affordable products quite like ours. But as we noticed when we spoke to Owen, he said that he quite likes using his cane. So that is probably our biggest competitor. But our hope for our product is that it will either be used with the cane or used entirely alone, with the benefit of not being a hands-off device, so you don't need to be carrying it around. And it can just hang there, and it's a lot. You can have more things in your hands, and hopefully people would take that into consideration. Thank you.
Great job personalizing the design of your product for your community partner. Team Silly Ducks will now respond to questions from our judges for 4 minutes. Go ahead.
So yeah, I had a quick question. What was the biggest challenge technically putting the device together? Like, what did you run into that you maybe didn't expect and you kind of had to overcome to make it work?
One of our biggest challenges was the fact that the battery we wanted to use was not strong enough for the vibration motor. So until we find a strong enough battery, we are going to have to use the Chromebook as a power source.
Not ideal.
Yeah, hi, great project. What did you guys look at any other sensing technologies outside of the ultrasonics to, determine distance or whatever it was you were looking for?
Well, this our participation in Project Invent started through a class we were taking that was focused on Arduinos and the specific ultrasonic distance sensor, and there were the LED lights and a bunch of guides. So we started off just testing out the different things, and we were like, oh, look at this, maybe we can figure out how to incorporate this into something. So we never really looked at alternatives to the ultrasonic distance sensor. We just looked at how we could improve it and make it better.
Hey guys, I know you mentioned that a lot of this was designed specifically for your community partner, but as you think about generalizing it, what are the things that you think would be different in, you know, taking this like it was made for one person to just making it like a product that could be used by a lot of people?
Well, we're hoping to make the product itself smaller, so it would be probably a bit harder to do like customizations like stars that like what we had for Owen, but probably still have maybe a different texture, so you can still have a softer casing like felt, so it's softer touch and different colors. And we were considering, because as of right now it just like hangs around your neck, we were considering doing like a more kind of like a belt type thing, so maybe it's a little bit lower and it's not like bouncing on your chest as much, so you can feel the vibrations a little bit more consistently.
Cool, great.
I was really curious. You said your cane is the closest competitor. Building on what Vinny's question was, which was very similar to mine, have you thought about this in other uses, like perhaps folks that are further visually impaired, or also like maybe have some particular challenges in nonverbal ways? I was curious if you thought about expanding your product into those zones as well.
I think we were focusing mostly on making a product that would work for Owen and for people in our school specifically, because our situation here, our school is actually in a mall. So we have like all the walls look the same. It's kind of like a maze because it wasn't designed to have so many classrooms. And then we have escalators as our main stairs, but they constantly break. So the stairs that we usually use are in the corners off to the sides. You really have to like navigate around the building, and the stairs aren't like straight up and down, they have turns. So we were hoping that the device would help Owen navigate the stairs, with considering the turns and how many students are going up and down, and make it easier for him to find his way to the stairs, up the stairs, and to his next class.
Great, thanks, judges and Silly Duck. Appreciate that. All right, our fifth and our final pitch is Drainer Pot from Leaf Charter School, Alstead, New Hampshire. Drainer Pot is a countertop, all-in-one pasta cooker that boils, drains, and strains so that you don't have to.
How will we do this? Can this work? Can we really do this? Does this solve the problem? Hi, I'm Allie, and I ask a lot of questions. I'm usually the one asking, how will this actually work? It's up to me and my whole group to figure out what the answer is. We originally had a different community partner named Sandy. We had a very good relationship with her, and she was very kind. Her main problem was she couldn't walk upstairs or climb mountains because of her fractured knee. We enjoyed working with her, but at a certain point she had surgery. After this, we were no longer necessary on her journey. Instead of giving up, we pivoted to our new community partner, Claire. Our new community partner is Claire. She has EDS in pots. Claire commented, "I love cooking, but I have trouble." We studied her medical conditions to properly help her. She has trouble pouring and moving pots. Like Sandy, she is a very wonderful community partner. Because of Claire's EDS in pots, it's hard for her to make dinner. POTS is characterized by a blood circulation disorder. This causes Claire's heart to beat faster than normal. It makes it hard for her to stand for long periods of time. She also has EDS. EDS is a syndrome which weakens the connective tissues. This causes Claire pain when pouring heavy pots. Like Sandy, she is a very wonderful community partner. With our invention, we plan to help her. Our group has gone through many invention ideas. We started with a pot with a removable bottom. We completed a Pew matrix. A Pew matrix is the type of matrix which determines what design is best according to to its criteria. We decided our last adventure was too risky since Claire told us, "I'm afraid of being burnt." This is when we decided on our new idea.
The drainer pot helps anybody who wants to make dinner right beside their sink. Our project is based off of a coffee urn, and it works by draining the water out of the pot but leaving the food inside. We believe this will help Claire because she can make pasta right beside her sink and no longer has to strain her wrists by pouring the pot or by carrying it from the stove. Claire stated that I think it would be able to fit well into my kitchen. There are many people with similar conditions to Claire. Our project will be able to help the lives of many people and will make it easier for people to make dinner. We hope to achieve big things with the drainer pot. Starting off with the built-in heating system, this means that you won't have to carry it from the oven to the sink. Next, we've got the draining system, where there's a filter in there, and all you have to do is hit this knob and all the water will drain out. There's also a timer for cooking the pasta. When you're done cooking the pasta, you lift out the basket, and it's quite as simple as that.
This is our timer for our pot invention. When you press this button, it adds 1 minute. When you press this, it adds 5. When you press both, it'll add 30. When you press the logo button, it'll start to count down and make a sound when it's done. It will just repeat until you shake it.
This is our competitor matrix. In doing research, we found existing products with similar features, but there is no product on the market that combines all the features together like ours.
Our next steps for our project is to create a working model with no issues. We were told by Claire that this could be used for more than just pasta water, which is great. I will be able to give this a design many purposes in the kitchen, she said. Our project is going towards the right direction. We will buy a working coffee urn and implement a valve system into it.
Thanks for listening!
Drainer pot, existing appliances to inspire new ideas for your community partner. Way to go. Team Drainer Pot will now respond to questions from our judges for 4 minutes. Go ahead.
I have to ask you, what made you think of the coffee urn when you were talking about your pivot? How did that come about?
Okay, I'll take this one. So we just kind of looked at a coffee urn and we were like, hey, what if we implemented a system of making pasta in that? And we were like,
Hey guys, love the video. So building off of the coffee urn question, I'm just curious. It feels like this is one of those things where there are so many different ways that you might have conceived how to come up with this solution. I'm curious, without going into too much detail about other things you considered, what problems did you encounter while you were prototyping that this final design solved?
so, you want to answer?
The main problems we had were getting it up to the right temperature to boil the pasta and pasta blocking the spout.
I would also like to mention one of our past inventions, our original invention when I originally was in a different group, but I joined this group, and their invention was you had to take out the bottom and the water would drain out from the bottom. And I was like, guys, how will your hands not get burned in this instance? And so we were like, okay, we need to think of a different idea that will end up in us not having all burned hands.
Thanks.
So do you guys have a working prototype right now? That the one that you showed is
We're
Did
still
you guys
working
actually successfully cook pasta in there? Did it work?
We're still working on the heating feature. We plugged it in and an outlet broke. So we're still working on that.
Okay.
So it sounds like you guys had a lot of fun doing this project. What was the most exciting part of the process for you?
Okay. I like making like the slideshow and the script and everything. I like doing all that stuff. I made most of that slideshow. I want to brag, but I'm usually not in a group with these people. So that was nice. I mean that as a compliment. Great working with you.
All right, y'all, that wraps up our pitches. Congratulations to all of our brilliant student team and amazing support networks of teachers, mentors, and family. Our panelists will now head off to another room where they'll have time to deliberate and decide on our 2 awards.